On Tuesday, we took a look at a South African flat earther. And today we're back and we're keeping it close to home. Density, buoyancy, and gravity. These are concepts flat earthers have been struggling for quite some time. And they can't seem to wrap their head around that you can't have density and buoyancy without gravity. And it seems like we need to add potential energy to that list. Hi everyone, welcome back to the channel. I'm Heinrich and I'm the real nuclear physicist. Today we'll be taking a look at how Flatzoid seems to think that SciManDan does not understand density, buoyancy, and potential energy.
What is Mikey doing here exactly? I think his point, and the usual flat earther stance on this, is that his phone is denser than the air around it, therefore it falls. Well, okay, but my phone is also denser than the air above it. In fact, if you want to be really technical about it and really accurate, the air above it is very, very, very slightly less dense than the air below it. So why doesn't a phone move upwards if that's the case?
That is an excellent point, SciManDan. And it's a question I am yet to hear a flat earther answer. Why is there an inherent down force? Density and buoyancy will only work if there is a downward force to oppose.
Glad you asked this, Daniel. Since you are SciManDan and you claim to know so much about science and physics, it's weird that you would ask such a rudimentary question. Have you never ever heard of potential energy?
Yes, it does have potential energy when it's lifted from the ground. But the potential energy it has is gravitational potential energy, which is energy imparted to an object due to its position or relative position in a gravitational field. The equation for potential energy or gravitational potential energy is E, which is your energy, is equal to m times g times h. M being the mass of the object, in this case the phone, g, the gravitational acceleration, which is 9.8 meters per second, more or less everywhere. It does change as elevation changes quite slightly. And then h, of course, the height above the reference point. So if you move a 10 kilogram brick 10 meters above the ground, it would have 10 times 10, which is 100, times 9.8, which gives us 980 joules of potential energy. So, just like density and buoyancy, gravitational potential energy depends on, you guessed it, gravity.
Anyway, let's go to the basics. You see, this is SciManDan holding his cell phone. Was his cell phone automatically in his hand? No, he had to pick it up. Now, what's going to happen when he's going to lift the phone? What happened? He imparted potential energy to the phone.
Yes, lifting the phone further imparts more potential energy to the phone. But the key word again is gravitational potential energy, not just potential energy, because we get different forms of potential energy. Elastic potential energy, chemical potential energy, electrical potential energy. So we need to be a bit more specific. And because we're moving in the gravitational field of the Earth, it's gravitational potential energy.
Now, when he lets go, what's going to happen? It's going to turn to kinetic energy, and thus it sinks or falls in. Depends on opinion.
If you let go of the phone, yes, it will fall. That's also due to gravity. But let's take a look at this example. If we disregard air friction, this is a prime example of the conservation of mechanical energy. And since you are from South Africa, I personally know that if you had science in school, you would have done this, because conservation of mechanical energy is part of the school curricula that we have here.
So yes, we see the phone is denser than the medium it is submerged in. Why would you expect it to go up just because it's less dense? It's still denser than from where you picked it up. Hence, it's out of its equilibrium.
If we drop the phone in a vacuum, the space around it would be infinitely less dense than the phone itself. Now the question is, what causes the phone to go down and not left, right, or up? That's why there must be an inherent down force, because something is pulling the phone down.
You know, when it's on the ground, it's in static equilibrium, or in your hand, again, static equilibrium, because you are supporting.
It might be in static equilibrium, but that does not mean gravity is not acting upon it. And like you said, the phone is being supported by the hand. So the hand stops it from falling because the hand is opposing gravity. Like I've said numerous times, gravity is by far the weakest of the four fundamental forces. Why? Because it's dependent on the mass of an object. So the lower the mass, the smaller the gravitational force.
So once you let go of the phone, you can no longer support it. Thus, the potential energy has turned to kinetic energy and seeks its relative equilibrium.
It's kind of obvious that if you let go of the phone, your hand is no longer supporting it. And yes, then it will fall. It would accelerate towards the ground. And guess what that acceleration value would be for the phone as it approaches the ground? 9.8 meters per second. And when something falls only under the effect of gravity, we call that free fall. Once again, something you would have done in science class.
The phone moves down for a reason. Why don't you ever think about that one, Mikey, yeah?
Like we've seen today, potential energy, just like density and buoyancy, is extremely dependent on gravity. Without gravity, these concepts break down. If you enjoyed this video, hit the like and subscribe button. I'm Heinrich, the real nuclear physicist, and I'll see you next time.